And welcome to Ladyada.
Hey everybody, welcome to Ladyada again. Summertime break is over. Now it's nice and fall. Our kiddo is in 3K, and so we'll probably see us do a couple of videos until mid-November when we're out.
We'll figure it out. We have a bunch of things planned so we can have a lot of video content and more. So kick it off.
Okay, let's kick it. All right, so I have been working on a bunch of hardware. We didn't do shows for a few weeks, but stuff still happened. So first up, I did make a design and tester for the PCM 5122. Actually, I got the tester going today. So how about we just show that on the overhead? So let's go to the overhead and I'll show this off. So the PCM 5122 is a really nice, quality DAC. This chip has actually shown up in a bunch of Raspberry Pi hats and bonnets and stuff, and we might do one too because the I2S DAC that we used to use, I'll show that when we go back to the computer, it got discontinued, and the PCM 5122 is not too expensive, and like I said, it's really high quality. It's got a lot of nice configurability. One thing that's kind of neat about this is compared to the PCM 5102, which sounds very similar, which is very popular, which has similar quality. The 5102 is a hardware only. You basically, which is really great. You just pipe I2S into it, and audio just comes out. There's, you can do a couple of things with configuring the de-emphasis, the gain, the mute, but for the most part, it's what you get is what you get. What's nice about the PCM 5122 is it has 3 modes. It can do I2C config, SPI config, or hardware config. So by default, I have it shipping in hardware config. And then if you pull, I think, the mode 2 pin high, it goes into I2C mode. And then what's cool is you can do stuff like, software gain and software mute and, swapping channels. And I think there's even a little bit of a DSP block inside, so you can do treble and bass adjustments, and there's Linux kernel support for that. So, and there's driver support for a lot of RTOS chips for this DAC. So, because it's a very popular one, it's low cost. So, this is the tester. I'm using an RP 2040 to test it, and I basically test all the GPIO by setting different things. One thing that's nice is over I2C mode, a lot of these pins become would be for hardware configuration, like the gain and format and de-emphasis and filter. Those become just generic GPIO, so I can toggle those to test that they're properly connected. And then I test the I2S output. Here I made a mistake. I forgot. You have to have the I2S pins in a certain order for the RP 2040 because it uses PIO. But other than that, I think I can even maybe plug this in. Hold on. This is not long enough. So many cables everywhere. Let's see, what is this cable? I can plug this, and I can plug this one in. Got some e-ink stuff I'm working on too. Is this powered? This is not plugged in. Let's plug it in. Yeah, so you can see when the test completes, this lights up and it beeps. And, that makes you know it's good. So we'll get these into the shop really soon. And then, like I said, I'll probably do a Raspberry Pi hat or bonnet with that. Another little chip that I did this week, it's going to be in the shop soon, is this SPA... SPA06003. This is just kind of your kind of generic barometric pressure and temperature sensor. I normally wouldn't even really stock this because I really feel the Bosch sensors are good, but I do see this particular chip show up in quadcopters and stuff. And so I was well, if somebody really needs a very low cost, honestly not terribly accurate or precise, but still, you want something. It's a very low cost sensor. Maybe a good pairing for the HT20. They're both inexpensive, and so you put them together, and now you've got pressure, humidity, and temperature for very little. So those got done. Also, the e-ink bonnet will also go in the shop this week. So it was the SPI. Yeah, so I like the PCM 5122. The only thing about it is it's line out. It's not even headphone out. So, if you want, it's only good if you're pumping it into something else that's amplified. But what's nice about it is even with I2C control, unlike the TLV DAC, you don't need to do the PLL config. It has auto detect. It will detect that there's no M clock, but there's a B clock, and it will automatically set up all the PLL for you so that you can have audio come out, which it's a really nice little chip. I see why people like this a lot. Stuff I'm working on is 2 chips I'm working on. So one is a few weeks ago in the Great Search, we talked about 24-bit ADCs over I2C. We have the NAU 7802, but it's honestly really, I don't think it's very linear. I mean, it's probably okay for weight scale measurements for bridges. What's it called? Sorry, I forgot the name. It's the I'm never gonna remember the name. Whatever the metal bits that you strain gauges.
Yeah.
The strain gauges, but they're for weights. Are they called something different? Sorry, I'm looking at a strain gauge load cell. There you go. Sorry, I don't deal with them very often. The NAU 7802 is great for strain gauge load cells, but if you wanted to connect, the person who was asking specifically wanted to use the 24-bit ADC for reading an RTD, so a very high precision temperature sensor. Let me just go to the overhead at the computer real fast. I'll just show the difference. It's been a couple weeks.
What was that?
Can we switch to the computer real fast?
Oh, yeah,
I'll show the difference. Yeah, I'm like reacclimating to what am I working on? So these are strain gauges, and they're very they're not imprecise, but usually have to do a little bit of calibration to get them going. But what they wanted to measure was RTD sensors. And these are very precise. They'll give you excellent temperature measurement. Basically, the quality of the temperature measurement is dependent more on the ADC than on the sensor itself. They're very good and very reliable. This particular sensor is excellent for 0 to 280 degrees C. You can easily get 0.1 or better degrees C resolution accuracy, but you do need to have a good 24-bit ADC to do that. All right, so then back to the overhead.
Alrighty.
Thank you. Sorry about that. So I got the ADS 12122CO4. I think when we looked in the Great Search, there was the ADS 1219 or 1220, and basically one of them was really good for differential. So I think this one has a less common mode range, but has a much better programmable gain amplifier. And so I might actually end up making a breakout for both chips, but I started with this one. And I used Claude code for this. So let's go back to the computer. Actually, I got a bunch of stuff done with Claude in between watching the baby. Sorry, Claude. I'm searching for the ADS. Yes, this is still private because I haven't published it. But what I'd like is actually now I just have Claude do the commits, and so you can see what got that. Library is not fully complete. One thing that I'm learning a little bit, I'm kind of experimenting more with Claude, is Claude MD files. So one thing that I noticed, maybe I'll show my prompts. Claude, Claude we know. So I have a list of prompts. You can actually see this live, by the way. This is totally not secret. There's nothing private or secret about this stuff. This is just my checklist for initialization. And so, I have some prompts that I kind of copy and paste just to get it started. And the thing is, I'm often at different computers, sometimes at my desktop, sometimes at laptop. So I don't have these as a global Claude MD yet. I'm still working on that. I'm one of those people who's it takes me a while to kind of catch up to the latest. I know that there's more and more stuff, but this has worked out for me.
Yeah, you're so far behind. You're only using cutting edge, whatever these are, autocomplete
Yeah, no, this
LLMs.
is, but it's like it's working out for me.
You're pretty. No, I'm saying you're pretty on the cutting edge here. I don't think there's a quote community of people that are willing to talk about their use of these tools in the electronic world because
Yeah,
they're using them, they're not talking about it, or they're terrified and they're saying, "I'm not going to do it." But no one's really talking because it's got a little highly competitive too. But
yeah.
I like that you're showing how you're doing it.
One thing that's interesting is like, you know, you can see like sometimes I have to like tell it like do not delete file. Like, you know, I have like one mistake, like I see it's like, oh, I was like, oh, can you like move a file? And it's like, I'll delete it. And I'm like, no. So I have
This
to like,
is so weird because, like I've always said, computers used to be precise. If whatever it would do, whatever you did, it was a 1 + 1 is 2. Now it's like, okay, 1 + 1 is 2, but never, never, never. Just please don't put 5.
yeah,
Like,
yeah.
there's no reason to put that except for like, oh yeah, I kept putting 5. So what did you do? I told them not to put 5.
Type of 5.
Okay.
Yeah.
Okay.
So at the end now I put the context into initials, which I think is called, it basically just calls it Claude.md. And I say add to the git ignore so you don't commit it. Not that I care, again, it's like if you want to commit it, I just like, don't want somebody else to like accidentally load it and be like, why is my Claude acting weird? It's like, because I saw these setups. But that's actually working kind of nice because it means that what I can do is after I go through this initial context setting up where I basically, you know, and I keep adding like lines to this context setting up prompt because I'm like, oh shit, like there's these situations that it doesn't know about and I have to like, you know, tell it. You know, like I tell it how I like to do Doxygen. I tell it how I want to, you know, what to do with the PDFs. You know, one thing is sometimes I get PDFs that are really big and I tell it to split, tell it, you know, convert the PDF to text. But then I have to tell it, hey, find the section with the register map and pull that out because especially like TI data sheets, they can be like, you know, 300, 400 pages. But the register map is not that big. I just want the register map section. And then it can refer to the register map. But this is really nice because another thing that happens is people who use Claude know it. Sometimes it's just like you think you have it doing something and then kind of in the middle it's like, hey, I'm going to like compact the conversation and reset your context. And like sometimes I didn't see it because it would happen. It would like fly by and I'd be like doing an email while I'm waiting for it to finish. And I'd come back and be like, whoa, you like got stupid. It's just, it lost the context. So, you know, I'm trying that. I'm also going to try agents. One thing, for example, is like, hey, before you do a git commit, always Clang format and make sure that the Doxygen is set. So that kind of stuff, you don't need that to like plump up your working context. Like my working context should only be, you write the functions, I want you to know the history of all the functions and registers that we've done, but I don't need it to, or like, for example, when one thing I do is I have it compile, upload, check the output to verify that it's, you know, correct. That part actually doesn't need to be part of the main context. Like I would like to branch off, do the compile, upload, and test, and then come back and erase that from the context memory because I don't, you know, when it comes back, it should assume, like it should only come back to that branch of conversation once it knows, yes, I tested it and it worked completely, right? I just need to know good. I don't need to know, because, you know, when I compile, you know, the compilation output is huge. Now that's all entered into your context and it's just like it's not useful. Like you just added a couple thousand, maybe 10,000 tokens for nothing. And like the output is also like very wordy because I have every I2C interaction. So, you know, I'm learning and tweaking basically how to improve my context usage. So that's the ADS 122. And then, okay, let's go back to the overhead. I'll show the last thing I'm working on. And the other one that's in progress is this ADS. I think we also talked about this both on INPI and the Great Search. So this is an extended voltage, PPS capable, I2C configurable USB PD sync. So it can do up to 28 volts. So that's the extended voltage because most USB-C, you know, the older ones end at 20. And then another thing it can do is it can do variable voltages and variable current limiting if the power supply supports it. The only thing is that this is like this is a very different chip. It's very raw. Like you kind of just get these like, you really, so I've written a library for interacting with it, and I'm able to interact with the chip. But it's very like, it's a little bit weird in how it handles like connection disconnection. Like it doesn't, you can't talk to it over I2C until it's connected, which is okay, but you kind of have to, like, it's not a little unusual in Arduino. Like usually you would just, you could say like, hey, I'm talking to the chip because I'm providing you some 3-volt power, but the negotiations haven't completed. It won't actually even like respond until negotiations are completed. And then when it does, it sets like a bit high, and you have to catch that bit. Like you have to read it and then immediately get the reports out. So, I mean, I'm going to get it working. It's just like kind of a weird, the way they designed this chip is a little bit unusual. I don't like when chips make it so it's like, oh, if you didn't catch that this bit was red, like it went high and you didn't catch it in time, you don't know where you are. Like you can't ask it later. Like, have you finished loading? Have you finished connection? Like there was only like an IRQ. It's a little bit weird. And then I think is that it? I think that's it for my list. Yes, that's what I'm working on. So the PCM5122, I just finished the tester, so this will go to the store this week. The ADS122 CO4 I'm wrapping up, and this is kind of in progress. And then I have a bunch of other stuff on my desk that'll get done. So stuff's going to come out, but you'll see, again, there's, I'm going to try to get as much stuff done before mid-November when I go on my leave. Okay, so let's head over to the Great Search.
Okay.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses the power of engineering to help you. Yes, you find your things on digikey.com. Ladyada, what are you looking for this week?
Okay, so we got it.
Wait, can't you just type into the Google Gemini Nano Banana and get the answer? Why can't, seriously, just before you start, this is the Great Search. Why can't you just type in something, because AI is the new thing I hear. Why can't you just type in what you're looking for and find it?
Okay, good question.
Right?
Because some people are
Great
like,
answer.
How come I can ask
My segment's called The Great Question.
the great question?
Yeah.
Okay.
42.
It's an excellent question.
Yeah.
So the reason is that the lowest level answer is and LLM AI models are trained on what content is on the internet. There is not a lot of content on the internet on speccing parts and part specs, because that is contained in data sheets and it's not extracted into a human language.
You're doing it though.
Yeah, because it's like I have expertise, but I'm doing like predictive behavior based on past expectations, not hashing and slicing existing information. Like there's a lot of code on the internet, like tons and tons and tons. And so if you've trained an LLM on code, it's very easy for it to create compilable code. Not necessarily the correct code, but at least it does compile. Whereas components come and go very quickly. And also, like I said, knowing how to parse out the data sheets and specifications is non-trivial. It's if people didn't discuss that part on Reddit a lot, you're not going to have it show up in AI, which is actually true. Like, if I've actually asked AI, like, let's say I'm building a project, and it will give me a very generic Reddit-y response, like you should use a microcontroller like an Arduino, but it won't. It doesn't know specs. Like I said, well, I need a microcontroller that has this particular specification. It kind of falls over and dies, which is actually something we're talking about not in this Great Search, but the next one, because we need a very specific spec ADC. Okay,
Hey, great answer.
That's the short of it. And I'll tell you another thing. For example, this week's Great Search, we had someone contact us and they wanted to make a DIY spectroscopy machine, I guess. And so a common sensor you use is a linear CCD. And this is a sensor that has pixels arranged in a line. It's like a camera sensor, but the camera is exposed. It's long and it has a lot of pixels, and you can read from the sensor. So a very, the one that they mentioned is like, well, I like the TCD 1304. It has many pixel sensing elements. And it comes in a line. I don't know if I can open this image. It's a SIRDIP through a hole. Let's see if I can get a data sheet in English. This was used, for scientific purposes. Most of it is, there's not actually that many pins because you shift out the analog sensing information, and it can measure light and dark levels. It only does monochromatic. But so what you would do is if you had a prism, you put a light in, and it splits the prism into colors, and then you shine that line of spectrally separated light onto the sensor. You could take a snapshot, and you can read what wavelength colors are contained within the light that you split before the prism. So that's basically what it is. So they said, hey, can you make like a breakout for this TCD 1304? You need to be high sensitivity and very fast, right? You can't just use like cadmium sulfide sensors. Like, you actually need them to be tightly packed and very sensitive. So I was like, oh, okay, well, let me just see if like DigiKey has this part. So I go to DigiKey, you type this in, and you get, like they don't have it. It's obsolete, non-cancelable. I mean, you might be able to still get some. This is active, but it's pretty much unavailable, and it's fairly expensive. So I thought, like, let's go look for other linear optical sensors. Maybe there's something else that DigiKey does stock, maybe more available, more affordable, that could do the job as well. So we're not going to get the exact same thing, but let's look for a image sensor. Let's go back to the image sensor category. And there's a lot. And one thing is that there are a lot of camera sensor modules are going to be this one is actually one that we've used, the MLX. We actually covered this in a couple of videos before. This is a thermal camera sensor. We don't want that. We want something that you shine a light onto. There's also these this is a raw image sensor, and this is really cool if you want to make your own image sensor. You put a lens on it, but it's not linear. I want something linear, and ideally also long enough that you could, when you do the spectral separation, you have a little bit of space to work with. So let's look for only active, stacked. And we want one that it's only linear. And so you'll see there's like the times, V, there's like horizontal and vertical. So we actually only want the 1Vs. So these, and then I'll pick up the dashes just in case. And then let's see. So that really cuts down. So it's like basically from the 2,000 options, 2,400 options, we now have 45. So you can actually do this and just take a look at what comes up. So some of these are just, they didn't have the specification. Let's move the resolution. Where's the resolution? Active pixel array. Can I pick this up? Yeah, here you go. Okay, so like this one, is 1,000. But pretty much, anyone that doesn't have it just didn't. And then the TCDs do show up here, but again, they're not in stock. So I don't know if I can ignore these on semis. But let's look at, let's just look at the active pixel array. Pixel array. I would love a pixel array. That would be good. So it looks like the ones that are stocked and available, because again, at the bottom we have those TCDs, which are not really available. They do have a range from Espros Photonics, so it's a Swiss company, AG, and they do come in a couple different configurations. It looks like you can basically get 1,000 pixels, not as many as the TCD, which was 3,000, but maybe 1,000 is still good enough, like the image elements. And it's half the cost. And most importantly, there's a lot in stock. So, you're going to basically have a trade-off between, how big the pixels are and the resolution. But let's take a look. Data sheet real fast. at this series. So there's a couple different. I don't know why you would necessarily want one with fewer pixels, but maybe it's just the pixel pitch that you're looking for. I think the slowest data sheet in the world. We'll just hang out and wait. I feel like I'm in like the 90s, like waiting for my file to download.
Oh boy.
Okay, there you go. Okay, so high performance CCD. It looks like it can do 4 frames of storage, which is kind of nice. Pixel size in the micrometer. Single power supply. Package looks pretty easy to pick and place. I mean, it's ball grid, but the balls are kind of enormous. And has gain. You can do a region of interest. You can set like, I want to just look at one section. And gives you like a differential output. You configure it over I2C. So it's actually kind of nice. It's like a moderner version. Looks like you can also do, it's like a camera. You have shutter control. So this could be kind of neat. This sensor, but most importantly, it's stock. Looks like this is like the sensor that people would use for this kind of measurement. Again, it's not common. I mean, I think historically, if you look at like the TCD, they were like, you would use this for, measuring, like doing barcode readers. But the fact is, like, that's not how people just take a photo of the barcode now. It's actually cheaper to take a little image of the barcode and do image processing than to try to scan it with a laser necessarily.
Weird.
Yeah, it's like, things just got like cameras got cheaper. But if you don't want a CCD, this looks pretty good, and it's in stock and pretty straightforward to use. You configure it over I2C. Like the TCD, you do want to clock it out to get the analog voltage. You don't read the voltages over I2C. It's not fast enough because you really need to you want to get through it very quickly. 3-volt power supply, which is nice. So it means it's compatible. Looks like you might need to give it a clock or something, but yeah, and it's like, there's some configuration. I think you tell it what mode you want it to be in. So I think this would be, like binning, voltage amplification, which direction you want to read, and then whether you want it to maybe pulse out the data on its own or you want to clock it out. So yeah, it looks good. So this is what I would pick. It's in stock. There's a couple thousand of them. Lots of them available. So the 901, for example, is totally fine. 256 pixel sensor, whichever number of pixels you want. The pixel will be wider, so maybe you'll get better. If you especially have dim light and you want to have more surface area, you pick the resolution that matches the minimum number that you want. So you get the biggest pixel size, get the most light absorption. To get more precision, maybe even more accuracy. But if you want the highest pixel density, this one is good too. The EPC 901 series from S-Pros Photonics. So that's my pick for the Great Search.
That's
for
a great search.
linear CCDs.
Where in the world is that part I need? The Great Search with DJK.
I'm sad to say we must be on our way. So buy me whiskey, so I'm going far away, far away. Okay. We'll be back soon.
Thanks.
Okay, bye everybody. Look for some fun content we're going to be posting
Yes.
online this week and more.
We know.
Bye. We're getting there. Okay, bye-bye.